Good afternoon, everybody. So, in the last class, we discussed about the concept of semiconductor, conductor, and insulator. And also, we discussed about types of semiconductor. In that, there are mainly two types: intrinsic and extrinsic, based on purity. And again, based on added impurity atoms, extrinsic semiconductor can further divide into two types, like N-type and P-type semiconductor, right? So today I'm going to discuss the concept like s- PN junction diode. PN junction diode is also known as semiconductor diode. So what is PN junction diode andra? Here one P-type semiconductor and one N-type semiconductor forms a junction. Forms a what? Junction. It is a diode having one PN junction with two metallic terminals. It's a device having one PN junction with two metallic terminals known as what? PN junction diode or semiconductor diode. So when does this PN junction diode is said to be biasing? Andra, this semiconductor diode is connected to an external potential difference like battery. When you connect some battery, then the diode is said to be in what? Biasing. So in already we explained about what are the majority charge carriers present in P-type semiconductors, Sandra? Holes. Majority charge carrier present in the N-type semiconductors are what? Electrons. So holes having positive charge, electrons having negative charge. This PN junction diode is connected to an external battery, then only the diode is said to be in what? Biasing. Biasing. Before biasing, the what happens to the potential up at P side and N side andre when unbiased diode ಒಳಗಡೆ potential at N side always greater than potential at ಏನಾಗಿರುತ್ತೆ P side. Potential at N side is greater than what? Potential at P side. So whenever that PN junction diode is connected to an external potential difference like battery, then the diode is said to be in what? Biasing. How many types of biases are there ಅಂತಂದ್ರೆ there are two types of biases are there. First one, forward bias. Forward bias, you can call it as FP. And second one, reverse bias. Reverse bias, name it as RB. So when does a diode is said to be in forward bias andre? When P side of the semiconductor, P side of the junction is connected to positive terminal of the battery and N side of the junction is connected to negative terminal of the battery. Then only the diode is said to be in which bias? Forward bias. That is said to be in what? Forward bias. After biasing at the PN junction atra, this region we can call it as which region? Depletion region. Depletion region. At the depletion region, there is a fixed layer of ions are present. During towards P side, electrons are accumulated. Towards N side, holes are accumulated. These fixed layer of ions creates a potential difference. We can call it as a potential barrier. Last class ಅಲ್ಲಿ ಕಲ್ತ್ಕೊಂಡಿದೀವಿ. ಇಲ್ಲಿ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಅಂತ ಅಂದ ತಕ್ಷಣ ಸೊ P side is connected to positive terminal, N side is connected to what? Negative terminal of the battery connect ಮಾಡ್ಕೊಂಡಿದೀವಿ. What are the majority charge carriers are present in P side? Holes. Majority charge carriers are present in N side is nothing but electrons. When you switch on the battery, at that time, holes are having positive charge. This connected to what? Positive terminal of the battery. Hence, there is a force of repulsion. Repulsion and thus holes are rushed towards P side to holes are moves towards P side to what? N side. At the same time, electrons are present in the N side are repelled by negative terminal of the battery. As a result, Electrons also moves from N side to what? P side. As a result, in case of forward bias, size of the depletion region gradually decreases. In case of which bias? Forward bias. Why? Because holes are repelled by positive terminal of the battery and electrons are repelled by what? Negative terminal of the battery. As a result, size of the depletion region gradually decreases, and diode acts as a switch on. In which bias, Andra? Forward bias. One thing you should remember, forward bias is nothing but switch on condition. Also, we can call it as a diode conducts. ಅಂತ ಕರಿತೀವಿ. Diode what? Conducts. ಎಲ್ಲದೂ ಕೂಡ ಒಂದೇ ಮೀನಿಂಗ್. On state ಅಥವಾ diode acts as a conduction. So, what happened to the resistance in case of forward bias ಅಂತಂದ್ರೆ diode offers very less resistance. During which bias? Forward bias. Look here. So when we switch on the battery, we can increase the potential difference with the help of what? Battery. So for example, this semiconductor diode we can consider as a silicon. Silicon and potential barrier is about 0.7 volt. Increase in the biasing voltage from 0 V in volt, I in milliampere. We can measure current in terms of what? Milliampere. In which bias? Forward bias. So when potential difference is 0, at that time current also becomes zero. When we can apply potential difference of 0.1 volt with the help of battery, aga current becomes 0. Can apply 0.2, current also 0. 0.3, current also becomes 0. 0.4, at that time a slightly increase in current like 10 milliampere, 0.5 like 50 milliampere, 0.6 like 70 milliampere. Once we can give 0.7, ಆಗ 250 milliampere increase ಆಗಿದೆ ಅಂತಂದ್ರೆ this biasing voltage in forward bias, what we call this particular voltage ಅಂದ್ರೆ knee voltage. K silent, knee voltage. Knee voltage is also known as cut in voltage. Here, what is knee voltage or cut in voltage andra? But in forward bias, a particular biasing voltage at which current increases exponentially. What? Exponentially. We can plot a graph in forward bias. You can plot a graph of forward bias graph na plot ಮಾಡ್ಕೊಂಡ್ರೆ, so I in milliampere, so V in volt. In x axis we consider V in volt, and y axis we consider I in milliampere. So increase in the biasing voltage from 0, 0.1, 0.2, 0.3 and 0.7. Increase the biasing voltage, current also increases. Once it reaches the particular biasing voltage at which current increases what? Exponentially. This biasing voltage, name it as which voltage? Knee voltage. In which bias? Forward bias. One thing you should remember, during forward bias, P side of the PN junction is connected to positive terminal, N side of the junction is connected to what? Negative terminal. At that time, the size of the depletion layer gradually decreases and diode offers very low resistance in forward bias. In forward bias, what type of voltage we are going to get? knee voltage. Knee voltage is also known as which voltage? Cut-in voltage. What is cut-in voltage? During forward bias, at a particular biasing voltage at which current increases exponentially. Such a biasing voltage you can call as a knee voltage. Next, we can switch on to the next concept, reverse bias. So reverse bias is also known as switch off ಅಂತ ಕರಿತೀವಿ. Forward bias is also known as switch on. Reverse bias is also known as what? Switch off. If I consider this is the PN junction diode, when P side of the junction is connected to negative terminal of the battery and N side is connected to what? Positive terminal of the battery. Such a type of biasing, name it as which bias? Reverse bias. So we know that what are the majority charge carriers are present in P side? Holes. Majority charge carrier present in N side is what? Electrons. When you switch on the battery, this negative terminal of the battery attracts the positive charges like holes. Electrons are attracted by positive terminal. Holes are attracted by negative terminal of the battery. As a result, size of the depletion region gradually increases. During which bias? Reverse bias. In case of forward bias, the size of the depletion region gradually decreases. But in case of reverse bias, the size of the depletion region gradually increases. As a result, diode offers very high resistance. Diode offers very high resistance. Here resistance R is equal to, we can write delta V by delta I. Resistance offered by the semi-PN junction diode in which bias? Reverse bias. Here R is equal to delta V by delta I. And also, in case of reverse bias, the current is about microampere. In case of forward bias, we are going to get a current in terms of milliampere. In case of reverse bias, we are going to get in terms of what? Micro. Micro means what? 10 power minus 6 ampere. 10 power minus 6 ampere. And also, size of the depletion region increases. In case of reverse bias, we can plot a graph in third quadrant. V, voltage V in volt and I in, sorry, I in microampere. So increase in the biasing voltage. So current increases exponential at a particular biasing voltage. A particular biasing voltage, name it as VB. What do you call that? VB ಅಂತಂದ್ರೆ VB belongs to breakdown voltage. Breakdown voltage. In case of forward bias, we are going to get a knee voltage or cut-in voltage. In case of reverse bias, we are going to get what? Breakdown voltage. ಅಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ current in terms of what? Milliampere. ಇಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ current in terms of what? Microampere. ಆಯ್ತಾ ಅಲ್ಲಿ ಸೈಜ್ ಆಫ್ ದ ಡಿಪ್ಲೇಷನ್ ರೀಜನ್ ಡಿಕ್ರೀಸಸ್ ಇಲ್ಲಿ ಸೈಜ್ ಆಫ್ ದ ಡಿಪ್ಲೇಷನ್ ರೀಜನ್ ಇನ್ಕ್ರೀಸಸ್ ಸೊ ದಿಸ್ ಇಸ್ ದ ಡಿಫರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ವಾಟ್ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಅಂಡ್ ರಿವರ್ಸ್ ಬಯಾಸ್ ಬಟ್ ಆಲ್ಸೋ ಇನ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಸೊ ಅಲ್ಲಿ ಹೌ ಟು ಐಡೆಂಟಿಫೈ ದ ಡಯೋಡ್ ಇಸ್ ಸೆಟ್ ಟು ಬಿ ಇನ್ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಅಂಡ್ ಡಯೋಡ್ ಇಸ್ ಸೆಟ್ ಟು ಬಿ ಇನ್ ರಿವರ್ಸ್ ಬಯಾಸ್ ಅಂದ್ರೆ ಲುಕ್ ಹಿಯರ್ potential given to the P side, potential given at the P side must be greater than potential given at the N side. Then only the diode is said to be in which bias? Forward bias. Potential given to the P side must be greater than potential given at the N side ಆಗಿದೆ ಅಂತಂದ್ರೆ ಯಾವ bias ಆಗಿರುತ್ತೆ? Forward bias. ಅದೇ ತರ potential given to the P side is less than potential given to the N side ಆಗಿದೆ ಅಂತಂದ್ರೆ such a type of bias we can call as ಯಾವ bias ಆಗಿರುತ್ತದು? Reverse bias. I can explain with an example. The circuit symbol of semiconductor diode like this. So one horizontal line and then vertical line like this. Here you can call it as a positive. Here you can call it as a negative. So this is the P side and N side. So ಇಲ್ಲಿ potential given to the P side. For example, plus 5 volt I'm going to give. Here plus 2 volt ಕೊಟ್ಟಿದ್ದೀನಿ. P side ಅಲ್ಲಿ plus 5 ಇದೆ. N side ಅಲ್ಲಿ plus 2 volt ನ ಕೊಟ್ಟಿದ್ದೀನಿ ಅಂತಂದ್ರೆ voltage, illu kuda voltage. If the potential at P side is greater than potential at ಏನಾಗಿದೆ N side, such a type of bias we can consider. ಯಾವ bias ಆಗುತ್ತೆ? Forward bias. Such a type of bias we can consider forward bias. Suppose I can give one more example. So this is the P side, N side. Here I am going to give 0 volt. ಇಲ್ಲಿ +1 volt. N ಕಡೆ ಏನು ಕೊಡಿ ನಾನು +1 volt. P ಕಡೆ ಎಷ್ಟು ಕೊಡಿ ನಾನು 0 volt. And a potential given at the P side is less than potential given at the N side ಆಗಿದೆ ಅಂತಂದ್ರೆ such a type of bias we can consider ಯಾವ bias ಆಗುತ್ತೆ reverse bias. Diode acts as a switch on in forward bias. Diode acts as a switch off in reverse bias. So this is the idea about what types of biasing, forward bias and also reverse bias. So one of the most important application of semiconductor diode is rectifier. Semiconductor diode acts as what? Rectifier. So what is rectification? Before going to start rectifier, first we can learn rectification. What is the meaning of rectification, Andra? It is the process of conversion of alternating current into direct current, AC to DC. AC is also known as yav current? Bidirectional current. Bidirectional current into DC is also known as what? Unidirectional current. What is the meaning of rectification, Andra? It is the process of conversion of bidirectional current into unidirectional current. Such a process we can call as a rectification. The device used for rectification we can call as a rectifier. ಇಲ್ಲಿ how many types of rectifiers are there ಅಂತಂದ್ರೆ two types ಇದೆ. One is half wave rectifier. Half wave rectifier. Another one is full wave rectifier. There are two types of rectifiers are there. First one is half wave rectifier, and second one is what? Full wave. As the name indicates, half. And it only converts half of the input AC signal into DC signal. As the name indicates, half wave rectifier converts only half of the input AC signal into DC signal convert ಮಾಡುತ್ತೆ. As I indicate, full wave rectifier ಅಂದ್ರೆ it completes both half cycles of AC into ಏನು ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ DC. For PU board examination point of view, compulsory these two derivations are important. ಆಯ್ತಾ? Only it converts half of the input AC to what? DC. It completely convert input AC into ಏನು ಮಾಡ್ತಾ ಇದೆ DC. Now we can discuss some formulas related to what? Rectifiers. First, I am going to consider half wave rectifier. Half wave rectifier. Half wave rectifier. In case of half wave rectifier, the average output in one cycle is given by IDC is equal to I naught by pi. You should remember these formulas are important. Average output in one cycle is IDC is equal to I naught by pi and VDC is equal to V naught by pi. VDC is equal to what? V naught by pi. And next formula, RMS output voltage, VIRMS. IRMS is equal to I naught by 2 and VRMS is equal to V naught by 2. In case of half wave rectifier, RMS output is given by IRMS is equal to I naught by 2 and VRMS is equal to what? V naught by 2. And third formula, ripple factor. R is equal to IAC by IDC is equal to ripple factor IAC by IDC is equal to the value is 1.21. The value is what? 1.21. Ripple factor in case of half-wave rectifier is what? 1.21. And efficiency of half-wave rectifier, eta is equal to P output power by P input. In general ಆಗಿ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಪ್ಪ ಅಂದ್ರೆ 40.2. The efficiency of half-wave rectifier is 40.6, not 2, 40.6. So these are the formulas are important related to what? Half-wave rectifier. And also this concept is important. Ripple frequency in half-wave rectifier, in half-wave rectifier is same. Ripple frequency in half-wave rectifier is same as that of input AC, same as that of input AC. Input AC. So these are the formulas related to what? Half-wave rectifier. As the name indicates, half-wave rectifier only converts half of the input AC into the DC. Now we can switch on to the next one. Full wave rectifier. Full wave rectifier. In case of full wave rectifier, the average output is output DC, VDC is equal to the average voltage. V average is equal to 2 V naught by pi, and I average is equal to 2 I naught by pi. The average output voltage and current is given by 2 V naught by pi and 2 I naught by pi. And similarly, RMS output is given by VRMS is equal to V naught by root 2, and IRMS is equal to I naught by root 2. RMS value of voltage and current is VRMS is equal to V naught by root 2, and IRMS is equal to I naught by root 2. And third one, ripple factor R value ಎಷ್ಟು ಸರ್ ಅಂತಂದ್ರೆ 0.48 or 48%. Ripple factor for half-wave rectifier 1.21 and full wave rectifier is what? 0.48 or 48%. And efficiency of full wave rectifier, eta is equal to 81.2%. Efficiency of full wave rectifier is nothing but what? 81.2%. Here, this formula is important. Ripple frequency is equal to 2 times. Ripple frequency is equal to 2 times that of input AC. 2 times that of what? Input AC. Andre, in case of full wave rectifier, ripple frequency of full wave rectifier is equal to 2 into frequency of what? Input AC. So these formulas are important related to what? Full wave rectifier and also half-wave rectifier. Now we can switch on to the questions which is related to semiconductor electronics ಮೇಲೆ previous year questions ನ discuss ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. Okay, question number 1. You just go to the question number 1. So, to a germanium crystal, equal number of aluminium. Equal number of what? Aluminium. Equal number of aluminium and indium. Okay. Aluminium and indium atoms are added. Just remember, there are two types of dopants are there. One is trivalent, another one is what? Pentavalent. So give an example for trivalent impurity ಅಂತಂದ್ರೆ boron, aluminium, gallium, indium. Boron, aluminium, gallium, indium are the example for what? Trivalent impurity atoms. Trivalent impurity atoms. When trivalent impurity atoms are added to the intrinsic semiconductor, we are going to get ಏನು ಸಿಗುತ್ತೆ ನಮಗೆ extrinsic extrinsic p-type semiconductor. Extrinsic p-type semiconductor ಸಿಗುತ್ತೆ. p-type ಅಂದ ತಕ್ಷಣ what are the majority charge carriers in p-type semiconductor? Holes. Holes are the majority charge carriers. Electrons are the minority charge carriers. ಇಲ್ಲಿ to germanium crystal. Germanium is an example for intrinsic semiconductor or pure semiconductor. Equal number of aluminum and indium. Look here, aluminum and indium. Both are example for what? Trivalent impurities added to it. Then what happens to the germanium crystal ಅಂತಂದ್ರೆ germanium intrinsic becomes ಏನಾಗುತ್ತೆ extrinsic ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. Pure becomes what? Impure. Impure ಆಗೋದ್ರ ಜೊತೆಗೆ we are going to get ಏನ್ ಸಿಗುತ್ತೆ ಹಂಗಂದ್ರೆ p-type semiconductor. ನೆನ್ನೆ ಹೇಳಿದೆ p-type semiconductors are formed by what? Trivalent impurity atoms. That's why it becomes ಏನಾಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಹಂಗಂದ್ರೆ p-type. When which option is correct ಅಂತಂದ್ರೆ option 3 is right. Second question, minority carriers in a p-type semiconductor are minority charge carriers. They're asking majority ಅಲ್ಲ minority ಕೇಳ್ತಾ ಇದ್ದಾರೆ. minority charge carriers in p-type, majority charge carriers in p-type semiconductors ಅಲ್ಲಿ ಹೋಲ್ಸ್ ಆದ್ರೆ minority charge carriers in p-type semiconductors ಅಲ್ಲೇನೆ ಏನಾಗಿರುತ್ತೆ free electrons. Electrons are the minority charge carriers. Holes are the majority charge carriers in ಯಾವ type ಅಲ್ಲಿ p-type semiconductor. Next question. In reverse biased diode, should remember reverse biased diode ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. Reverse bias and now one thing you should remember, when p side of the junction is connected to n side and n side of the junction is connected to what? Positive terminal of the battery, then the such a type of biasing you can call as reverse bias. Andre ಇಲ್ಲಿ p-type semiconductor ಇದೆ, n-type semiconductor. p-type is connected to what? Negative terminal of the battery and n-type is connected to what? Positive terminal of the battery. Such a type of biasing, name it as what? Reverse bias. In case of reverse bias, the size of the depletion region gradually increases when the applied voltage changes by 1 volt and delta V is equal to, they are given 1 volt. The current is found by changes by 0.5 microampere. Delta I is equal to 0.5 into 10 power minus 6 ampere. Micro, it means what? 10 power minus 6. What they're asking? Reverse biased resistance. R is equal to question mark. R is equal to what? Question mark. You know the formula to calculate resistance during reverse bias. R is equal to delta V by delta I. R is equal to delta V by what? Delta I. Now we can substitute the values. So V andre 1 volt, delta V belongs to 1 volt and 0.5 into 10 power minus 6. This 10 power minus 6 shift into numerator. What happens? Minus 5 becomes ಏನಾಗುತ್ತೆ? Plus minus 6 becomes plus 6. Therefore, R is equal to 10 power 6 by 0.5. Now we can multiply and divide by 10 ಮಾಡ್ಕೋಣ. So 10 by 5 into 10 power 6 ಆಯ್ತು. So therefore, 5 2s are 2 into 10 power plus 6 ohm. The forward reverse bias resistance of the diode is nothing but ಎಷ್ಟು ಬರುತ್ತೆ ಹಂಗಂದ್ರೆ? So 2 into 10 power plus 6 ohm. And which option is correct ಆಗುತ್ತೆ ಹಂಗಂದ್ರೆ? Option 2 is right. Now we can switch on to the next question. When Unbiased. This word is important. Unbiased. PN junction. Unbiased ಅಂತಂದ್ರೆ there is no connection of external battery. There is no connection of what? External battery. ಒಂದು P side, ಒಂದು N side ಇದೆ. So there is no external connection battery ಇಲ್ಲ ಅಂದ್ರೆ ಏನ್ ಕರೀತಾರೆ ಅದನ್ನ ಅನ್ಸೈಡ್ ಅಂತ ಅನ್ಬಯಾಸ್ಡ್ ಅಂತ ಕರಿತೀವಿ. ಆಗ potential at N side always greater than potential at what ಏನಾಗಿರುತ್ತೆ P side. When unbiased PN junction potential at P side is equal to potential at N side. That is wrong. And potential is at P side is positive and there is not of negative. That is also wrong. Potential at P C is more than that of N ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. P is not. But potential at P is less than that of what N ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. That is the right answer. And option 4 is right. One thing you should remember, both P type and N-type semiconductor are electrically neutral. Both N-type and P-type semiconductors are what? Electrically neutral. You should remember because atoms are electrically neutral. So, Andre, option 4 is right. Now we can switch on to the next question. Forbidden energy gap of germanium is 0.72 electron volt. Given Hc, H is the Planck's constant and C is the speed of light in air or vacuum. They are given direct value ಕೊಟ್ಟಿದ್ದಾರೆ 12400 electron volt in terms of angstrom. The maximum wavelength of radiation that will generate electron volt pair is ಅಂತ ಕೇಳ್ತಾರೆ. They are asking to calculate lambda. Lambda is equal to what? Question mark. We know that energy of photon formula E is equal to ಏನು ಬರೀತೀರಾ h nu in terms of frequency ಆಗುತ್ತೆ in terms of wavelength ಅಲ್ಲಿ E is equal to hc by lambda. Our aim is to find out lambda. Therefore lambda is equal to hc by E. Lambda is equal to formula ಮಾತ್ರ hc by E. hc value they are given 12400 ev angstrom whole divided by energy gap of a germanium they are given 0.72 ev. Electron volt get cancelled and remaining unit is nothing but what? Angstrom ಮಾತ್ರ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. So therefore lambda is equal to 12400 angstrom whole divided by 0.72 can be done as 72 into 10 power minus 2 ಅಂತ ಬರ್ಕೋಣ 72 into 10 power minus 2. Now we can divide. So 4 ones are 4 eights are 4 threes are 4 ones are 3100 by ಏನಾಗುತ್ತೆ 18. Now can divide 9 twos are 18. This 10 power minus 2 shift into numerator minus 2 becomes ಏನಾಗುತ್ತೆ plus 2. And again 9 threes are 27. 31 ಅಲ್ಲಿ 27 ಹೋದ್ರೆ ಎಷ್ಟು ಉಳಿಯುತ್ತೆ 4 ಅಂದ್ರೆ 40 ಆಗುತ್ತೆ 40 ಅಂದ್ರೆ 9 fours are 36. Again 9 fours are 0.44. The 344.44 divided by 2 ಆಯ್ತು. Therefore lambda is equal to 344.44 whole divided by 2 into 10 power plus 2 ಇದೆ. So divide ಮಾಡ್ಕೊಂಡ್ರೆ 2 ones are 2, 2 sevens are again 14 ಆಗುತ್ತೆ 2 twos are 2s are therefore 172.22 into 10 power plus 2 ಇದೆ. So multiply ಮಾಡ್ಕೊಂಡ್ರೆ 17222 angstrom. So this is the right answer. Which option is correct ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ option 3 is right. So 17,222 angstrom. The wavelength of electron hole pair is 17,200 what? 22 angstrom. So next we can switch on to the next question. Pick out the statement which is not correct. Pick out the statement which is not correct. ಯಾವುದು ಸರಿ ಅಲ್ಲ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ವಿಚ್ ಇಸ್ ನಾಟ್ ಅಂದ್ರೆ ಯಾವ್ದು ತಪ್ಪು ಅನ್ನೋದ್ರ ಬದಲಾಗಿ ವಿಚ್ ಇಸ್ ನಾಟ್ ಕರೆಕ್ಟ್, ಯಾವ್ದು ತಪ್ಪಿದೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಲೋ ಟೆಂಪರೇಚರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಎ ಸೆಮಿಕಂಡಕ್ಟರ್ ಈಸ್ ವೆರಿ ಹೈ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಲೋ ಟೆಂಪರೇಚರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದ ಸೆಮಿಕಂಡಕ್ಟರ್ ಇಸ್ ವಾಟ್ ವೆರಿ ಹೈ. ದಟ್ ಇಸ್ ಟ್ರೂ. ಯಾಕಂದ್ರೆ ಸೆಮಿಕಂಡಕ್ಟರ್ಸ್ ಆರ್ ವಾಟ್ ನೆಗೆಟಿವ್ ಟೆಂಪರೇಚರ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಆರ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ವಾಟ್ ಟಿ. ಟಿ ಡಿಕ್ರೀಸಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗ್ತಿದೆ ಇನ್ಕ್ರೀಸಸ್. ಅಟ್ ಲೋ ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ಇಸ್ ವಾಟ್ ಹೈ. ಸರಿ ಇದೆ, ಬಟ್ ನಮ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಯಾವ್ದು ತಪ್ಪಿದೆ ಅಂತ ಕೇಳಿದಾರೆ. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ನೋಡ್ಕೋಣ. ಮೂಮೆಂಟ್ ಆಫ್ ಹೋಲ್ಸ್ ಇಸ್ ರಿಸ್ಟ್ರಿಕ್ಟೆಡ್ ಟು ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಓನ್ಲಿ. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಟ್ರೂ. ಹೋಲ್ಸ್ ಆರ್ ಆಲ್ವೇಸ್ ಜನರೇಟೆಡ್ ಇನ್ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್. ವಾಟ್ ಈಸ್ ಹೋಲ್ ಅಂತ ನಿನ್ನೆ ಓದಿದಿರಾ ಏನಂತ? ಎ ಪಾಸಿಟಿವ್ ವೇಕೆನ್ಸಿ ಇಸ್ ಕ್ರಿಯೇಟೆಡ್ in an valence band when electron jumps from valence band to conduction band after absorbing some external energy, right? That is also true. And third one, width of the depletion region increases as forward bias voltage increases in case of PN junction diode. That is width of the depletion region increases. Width of the depletion region ಏನಾಗ್ತಿದೆ ಅಂತ increases as the forward bias voltage increases ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So that is wrong. ಯಾಕೆ? ಆಲ್ರೆಡಿ ಓದಿದಿರಾ. ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಅಂತ ತಕ್ಷಣ the size of the depletion region decreases. The size of the depletion region gradually decreases during which bias? Forward bias. Reverse bias ಆಗಿದ್ರೆ size of the depletion region ಆಗುತ್ತೆ increases. This statement is wrong. That's why which one is not correct ಅಂದ್ರೆ option 3. Option 4 ಕೂಡ ಚೆಕ್ ಮಾಡೋಣ. In forward bias condition diode heavily conducts ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. That is also true. ಯಾಕಂದ್ರೆ diode acts as a switch on in ಯಾವ bias? Forward bias. Diode acts as a switch off in which bias? Reverse bias. Now, which one? It's just which of the following statement is wrong andre option 3. So that's why option 3 is the right answer. Okay, next question. In the case of forward biasing of PN junction diode, which of the following figure correctly depicts the direction of conventional current indicated by arrow mark ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ನೆನ್ಪಿಡ್ಕೊಳ್ಳಿ, ಇನ್ ಗಿವನ್ ಆಪ್ಷನ್ 4 ಅಲ್ಲಿ ಎಲ್ಲವೂ ಕೂಡ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಆಗಿದೆ. ಯಾಕಂದ್ರೆ ಪಿ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಬ್ಯಾಟ್ರಿ, ಎನ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಬ್ಯಾಟ್ರಿ ಅಂತ ತಕ್ಷಣ ಯಾವ ಬಯಾಸ್? ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್. Here also P is connected to positive, N is connected to negative. Name it as what? Forward bias. Here also P is connected to positive, N is connected to negative. Here also forward bias connected to positive, negative. Name it as what? Forward bias. But they are asking to calculate direction of conventional current indicated by an arrow mark ಅಂತ ಕೇಳ್ತಾರೆ. Forward bias ಅಂತ ತಕ್ಷಣ the size of the depletion layer gradually decreases. Why ಅಂದ್ರೆ holes are repelled by positive terminal of the battery, electrons are repelled by negative terminal of the battery. As a result, holes are moves from p side to n side, electron moves from n side to what? P side. Therefore, so direction of flow of current from p side to n side is p side to n side clockwise ಇದೆ, n side to p side ಏನಾಗಿದೆ anti clockwise. In which option is correct among the out of the four options ಅಂದ್ರೆ option 3 is right. ಅಲ್ಲಿ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಒಳಗಡೆ ಆಪ್ಷನ್ 4 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ದಟ್ ಈಸ್ ರಾಂಗ್. ಆಪ್ಷನ್ 3 ಇಸ್ ರೈಟ್. ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್ ಡ್ಯೂರಿಂಗ್ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಡ್ಯೂ ಟು ಹೋಲ್ಸ್ ಅಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂದ್ರೆ ಆಪ್ಷನ್ 3 ಇಸ್ ರೈಟ್. ನೆಕ್ಸ್ಟ್ ಒನ್. In which of the following statement the obtained impure semiconductor is of p type? p type ಬೇಕು ಅಂತಂದ್ರೆ ಕಂಪಲ್ಸರಿ ವಿ ಕ್ಯಾನ್ ಡೋಪ್ಡ್ ವಿತ್ ಯಾವ ಇಂಪ್ಯೂರಿಟಿ? ಟ್ರೈವಲೆಂಟ್ ಇಂಪ್ಯೂರಿಟಿ. ಟ್ರೈವಲೆಂಟ್ ಇಂಪ್ಯೂರಿಟಿ ಎಕ್ಸಾಂಪಲ್ ಆಗಿ ಬೋರಾನ್, ಅಲ್ಯೂಮಿನಿಯಂ, ಗ್ಯಾಲಿಯಂ ಆರ್ ಇಂಡಿಯಂ. Any one of the trivalent impurity is added to the intrinsic semiconductor, we are going to get extrinsic p-type semiconductor. Or among the four options ಒಳಗಡೆ germanium is doped with bismuth. Bismuth is an example for what? Penta. Pentavalent ಅಂತ ತಕ್ಷಣ we are going to get n-type semiconductor ಸಿಗುತ್ತೆ. That's why option 1 is wrong. Silicon is doped with antimony. Antimony is also example for pentavalent. Pentavalent ಅಂದ ತಕ್ಷಣ N type ಸಿಗುತ್ತೆ. Germanium is doped with gallium. Gallium is an example for what? Trivalent. Trivalent ಅಂದ ತಕ್ಷಣ we are going to get ಏನ್ ಸಿಗುತ್ತೆ ಹಂಗಂದ್ರೆ P type. Option 4 ಕೂಡ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. Silicon is doped with phosphorus. Phosphorus is also example for what? Pentavalent. Pentavalent ಅಂದ ತಕ್ಷಣ we are going to get N type semiconductor. ಈ 4 ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ವಿಚ್ ಒನ್ ಈಸ್ ರೈಟ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಆಪ್ಷನ್ 3 is right. Germanium is doped with gallium. We are going to get P type semiconductor. The next question. The width of the depletion region in a PN junction diode. Width of the depletion region, the size of the depletion region in a PN junction diode is increased by reverse bias, increased by forward bias, decreased by reverse bias, independent of biasing voltage ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅವ್ರೇನ್ ಕೇಳ್ತಾರೆ? Width of the depletion region in a PN junction diode increased by reverse bias. Increase ಆಗುತ್ತಾ reverse bias ಅಲ್ಲಿ? Increased by forward bias. That is wrong. Forward bias ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? Width of the depletion layer decreases. Decreased by reverse bias. That is wrong. Increased by ಏನಾಗುತ್ತೆ ಹಂಗಂದ್ರೆ reverse bias. In case of reverse bias, when P side of the junction is connected to positive negative terminal and N side is connected to what? Positive terminal of the battery, ಆಗ the size of the depletion layer gradually increases. In which bias ಆಗುತ್ತೆ? Reverse bias. Option 1 is right. The next question. In N-type semiconductor, electrons are majority charge carriers, but it does not show any negative charge. The reason is why already explained. P-type semiconductor and N-type semiconductors are electrically neutral. Why andre atoms are what? Electrically neutral. Option 3 is right. Next one. So these type of problems are important. ಈ ತರ questions na competitive exams ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ maximum time. Look here. So here there are two diodes are connected to an external battery. Those two diodes are biasing ಆಗಿದೆ. ಇಲ್ಲಿ D1 ಮತ್ತೆ D2. This is the positive, negative, P side, N side, N side, negative, positive, N side, P side. Look here. Diode D1, P is connected to positive terminal of the battery, N is connected to negative terminal of the battery. As a result, diode D1 is in which bias? Forward bias. Here P is connected to negative terminal of the battery, N is connected to positive terminal of the battery. As a result, diode D2 is in which bias? Reverse bias. That's why each reverse bias ಅಲ್ಲಿ the diode acts as a which condition? Switch off. ಯಾವಾಗ diode ಸ್ವಿಚ್ ಆನ್ ಆಗಿರುತ್ತೆ? In forward bias. ಈ ಎರಡು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಏನ್ ಮಾಡಿದ್ರೆ ನಾವು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡು we are only consider these portions of circuit. ಇಷ್ಟು ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ತೀವಿ because diode D2 is in which bias? Reverse bias. ಅಷ್ಟು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ the circuit has two oppositely connected ideal diodes in parallel. What is the current flowing? They're asking to calculate I is equal to question mark. We can use Ohm's law use ಮಾಡ್ಕೋಣ. V is equal to I into R. V is equal to formula ಇದೆ I into R. Therefore, I is equal to V by R. I is equal to V by R. R ಅಂತಂದ್ರೆ 3 ohm ಮತ್ತೆ 4 ohm ಎರಡೂ ಕೂಡ ಸೀರೀಸ್ ಆಗಿದೆ. We are going to get RS ಅಂತ ಕರ್ಕೋಣ. Here RS is equal to 3 ohm plus 4 ohm is equal to ಎಷ್ಟು ohms ಆಗುತ್ತೆ? 7 ohm. V ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ 12 volt divided by 7 ohm. Therefore, I is equal to 12 by 7 ಅಂದ್ರೆ 7 ones 7. 12 ಅಲ್ಲಿ 7 ಹೋದ್ರೆ 5 ಉಳಿಯುತ್ತೆ. ಪಾಯಿಂಟ್ ಇಳಿಸ್ಕೊಂಡ್ರೆ 50. 7 sevens so 1.71 ampere. ಅಂದ್ರೆ which option is correct ಆಗತ್ತೆ ಹಂಗಂದ್ರೆ option 3 is right. ಈ ತರ questions ಗಳು important. First we can neglect reverse bias diode. Now we can switch on to the next question. The figure shown, if the diode forward bias voltage drop is 0.2 volt, ಇಲ್ಲಿ 0.2 volt ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. Difference between A and B, the voltage difference between VAB is equal to question mark. VAB is equal to what? Question mark. Here, the potential across VAB, we are going to apply Kirchhoff law use ಮಾಡ್ಕೋಣ. VAB is equal to I into R ಅಂದ್ರೆ 5 kilo ohm ಇದೆ, 0.2 milliampere. Therefore, I into R ಅಂದ್ರೆ 0.2 into 10 power minus 3 into R ಅಂದ್ರೆ 5 into 10 power plus 3 plus ಇಲ್ಲಿ 0.2 voltage ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ plus again 0.2 milliampere into 5 kilo ohm, 0.2 into 10 power minus 3 into 5 into 10 power plus 3. So minus 3 plus 3 get cancelled, minus 3 plus 3 get cancelled. Therefore, potential across VAB is equal to 0.2 into 5 plus 0.2 plus 0.2 into 5. So multiply ಮಾಡ್ಕೋಣ, 0.2 into 5 ಮಾಡ್ಕೊಂಡ್ರೆ 1 plus 0.2 plus 0.2 into 5, 1, 1 plus 1, 2, 2 plus 0.2 becomes ಏನಾಗುತ್ತೆ 2.2 volt. In a potential across VAB, value becomes ಏನಾಗುತ್ತೆ 2.2 volt. And which option correct ಆಗುತ್ತೆ ಅಂದ್ರೆ option 2 is right. The next question. The energy gap in case of which of the following less than 3 electron volt? EG is less than 3 electron volt ಅಂತಾಸ್ನ such as solids are known as what? Semiconductor ಅಂತ ಕರಿತೀವಿ. Semiconductor. Energy gap is equal to 0 for conductor. Energy gap is less than 3 electron volt for semiconductor. Energy gap is more than 3 electron volt. Name it as what? Insulator. ನಿನ್ನೆ ಕ್ಲಾಸಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. ಇಲ್ಲಿ ಅಲ್ಯೂಮಿನಿಯಂ, ಐರನ್, ಜರ್ಮೇನಿಯಂ ಅಂಡ್ ಕಾಪರ್ ಮೂರು ಕಂಡಕ್ಟರ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಒಂದು ಸೆಮಿಕಂಡಕ್ಟರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅಂದ್ರೆ ವಿಚ್ ಒನ್ ಈಸ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ಆಗುತ್ತೆ? ಜರ್ಮೇನಿಯಂ. ಸೊ ಜರ್ಮೇನಿಯಂಗೆ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಸರ್ ಅಂದ್ರೆ 0.71 electron volt. Energy gap of germanium is 0.71 electron volt. For silicon, energy gap is equal to 1.1 electron volt. Gallium arsenide. Also example for semiconductor, the energy gap value EG is equal to 1.3 electron volt. For germanium, 0.71 electron volt. Silicon, 1.1 electron volt. Gallium arsenide, EG is equal to 1.3 electron volt. The next question. The density of electron hole pair in pure germanium. You should remember, pure antashna intrinsic. Intrinsic semiconductor alle intrinsic carrier concentration formula Ni is equal to Ne is equal to NH. Value they are given 3 into 10 power plus 16 per meter cube at room temperature. And doping with aluminum. Aluminum is an example for what? Trivalent impurity. Whenever trivalent impurity is added to the intrinsic semiconductor like germanium, we are going to get extrinsic P-type semiconductor. Hole density increases to means what? NH is equal to 4.5 into 10 power plus 22 meter cube. Now electron density in doped germanium, doped andre extrinsic ಒಳಗಡೆ electron density they are asking. Ne is equal to question mark. Ne is equal to question mark. In extrinsic semiconductor, extrinsic carrier concentration Ni square is equal to Ne into NH. ನೆನ್ನೆ ಬರ್ಸಿದೆ. Ni square is equal to Ne into NH. Our aim is to find out Ne. Therefore, Ne is equal to Ni square by NH. So Ne value they are given 3 into 10 power plus 16 whole square whole divided by NH value 4.5 into 10 power plus 22. 10 power plus 22. Therefore, simplify ಮಾಡ್ತಾ ಬಂದ್ರೆ 3 3s are 9, 10 power 32 whole divided by 4.5 into 10 power plus 22. This 10 power plus 22 shift into numerator. That plus 22 becomes ಏನಾಗುತ್ತೆ minus 22. Therefore, 9 by 4.5 into 10 power 20, 32 ಅಲ್ಲಿ 22 ಹೋದ್ರೆ ಎಷ್ಟು ಉಳಿಯುತ್ತೆ ಅಂದ್ರೆ 10. Therefore, 90 by you can write 45 into 10 power 10. 45 ones are 45 twos are. Therefore, 2 into 10 power plus 10. 2 into 10 power plus 10. Which option is correct ಆಗುತ್ತೆ ಅಂದ್ರೆ option 2 is right. Now, electron density in doped germanium will be 2 into 10 power plus 10. Option 2 is right. Next, we can switch on to the next question. The conductivity of semiconductor increases with increase in temperature because ಅಂತ ಕೇಳ್ತಾರೆ. Yesterday in the previous class, we already discussed how to increase the conductivity of semiconductor by increasing its temperature and increasing its what? Doping density. So whenever temperature increases, in case of semiconductor, conductivity also increases. ಯಾಕಂತ ಹೇಳಿದ್ರೆ conductivity is reciprocal of resistivity. Resistivity is directly proportional to resistance. Therefore, conductivity is directly proportional to temperature ಅಂತ ಓದಿದೀವಿ. Semiconductors are negative temperature coefficient of resistance. That's why temperature increases, conductivity also increases. How conductivity increases andre by breaking its covalent bond, number of charge carriers goes on increases. Number of charge carriers increases means what? Number of density of current carriers increases and relaxation time ಏನಾಗುತ್ತೆ decreases. Number of charge carriers ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ obviously relaxation time gradually decreases, but effect of decrease in relaxation time is much less increase in number of what? Density. And which option is correct ಆಗುತ್ತೆ ಹಂಗಂದ್ರೆ option 3. You should remember this formula. Sigma is directly proportional to what? T. T increases, conductivity also increases. Next question. Okay, positive hole in a semiconductor. We already learned there are two types of charge carriers are there. One is electron, another one is hole in case of semiconductor. Electrons are the negatively charged particle which are present in the valence band. After absorbing some sort of energy, electron jumps from valence band to conduction band by creating vacancy in the valence band. That created vacancy in the valence band creates ಏನ್ create ಮಾಡುತ್ತೆ a positive charge like what? Hole. A positive hole is a semiconductor in a valence vacancy created when an electron leaves the covalent bond. Electron leaves the what? Covalent bond. Hole is an imaginary charge. Hole is an what? Imaginary charge. And the option 4 is right. The next question. Okay, 220 AC supply connected between 2 points A and B shown in the figure. What will the potential difference V across the capacitance ಅಂತ ಕೇಳ್ತಾರೆ. ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಆಫ್ ವೇವ್ ರೆಕ್ಟಿಫೈರ್ the potential V RMS. So ಇಲ್ಲಿ V RMS is equal to V RMS is equal to V naught by root 2 ಇದೆ. Here they are given RMS value they are given. ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 220 volt. They are asking to calculate peak value of voltage. Therefore, V naught is equal to V RMS into root 2 ಆಗುತ್ತೆ. Therefore, V RMS ಅಂದ್ರೆ value ಎಷ್ಟಿದೆ 220 into value root 2. And which option is correct ಆಗುತ್ತೆ ಹಂಗಂದ್ರೆ option 2 is right. 220 into root 2 volt. Okay, next question. The resistivity of a semiconductor at room temperature in between ಅಂತ ಕೇಳ್ತಾರೆ. Direct question they are asking. Option 4 is right. 10 power minus 3 to 10 power plus 6 ohm centimeter. Centi means what? 1 centimeter is equal to 10 power minus 2 meter. ನೆನ್ನೆ ಬರ್ಸಿದ್ದು ನಾನು ಮೀಟರ್ ಬರ್ಸಿದ್ದೆ ಬಟ್ ದೇ ಆರ್ ಗಿವನ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸೆಂಟಿಮೀಟರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. minus 2 minus 3 minus 2 becomes ಎಷ್ಟಾಗುತ್ತೆ minus 5 and minus plus 6 minus 2 becomes ಏನಾಗುತ್ತೆ plus 4. Option 4 is right. Okay, next question. The forbidden energy gap for germanium crystal. Forbidden energy gap. Forbidden energy gap is nothing but what? Energy gap. The band gap. All are same only. Germanium crystal at 0 Kelvin is 0.71 volt. Silicon crystal ಕೇಳಿದ್ರ 1.1 electron volt. Gallium arsenide ಕೇಳಿದ್ರ 1.3 electron volt. Okay, next question. When a PN junction diode is in forward bias, which of the charge carriers flows in connecting wire ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ free electrons. Forward bias ಅಂದ ತಕ್ಷಣ size of the depletion region gradually decreases. As a result, majority charge carriers cross the junction and which of the flows the connecting wires ಅಂದ್ರೆ free electrons. Option 3 is right. Next question. Depletion region. Depletion region in an unbiased semiconductor diode in the region consisting of ಅಂತ ಕೇಳ್ತಾರೆ. Unbiased ಅಂತಂದ್ರೆ there is no external potential difference is connected across the PN junction. P side ಇದೆ, N side ಇದೆ. So ಇಲ್ಲಿ depletion region ಇದೆ. P ಅಂತ ತಕ್ಷಣ majority charge carriers are electrons, majority charge carriers are holes. N ಅಂತ ತಕ್ಷಣ majority charge carriers are what? Electrons. ಇಲ್ಲಿ unbiased junction ಅಂದ ತಕ್ಷಣ neither free electrons nor holes are present in a PN junction. Now we can switch on to the next question. The last question. The upper level of valence band and lower level of the conduction band overlap. Overlap ಅಂದ ತಕ್ಷಣ energy gap Eg is equal ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ 0 electron volt. 0 electron volt ಅಂದ ತಕ್ಷಣ such a metals are known as what? Conductor. Conductor ಗೆ silicon, copper, germanium. Carbon is an example for insulator. Silicon and germaniums are the semiconductor and copper is a very good conductor. And metals are good conductors. Option 2 is right. Okay, next question. A PN junction diode is connected to a battery of EMF 5.7 volt in series with a resistance of 5 kilo ohms such that in forward bias, if the potential barrier of the diode is 0.7, neglect the diode resistance, they are asking to calculate current. Your current I is equal to delta V by delta R, delta V by delta. So R is equal to delta V by delta I. They are given in ಕೊಟ್ಟಿದ್ದಾರೆ PN junction diode is connected to battery of EMF. V is equal to 5.7 volt and R is equal to the value they are given 5 into kilo 10 power plus 3 ohms such that and potential barrier V2 V1 is equal to 5.7 and V2 is equal to 0.7 volt ಕೊಟ್ಟಿದ್ದಾರೆ. They're asking to calculate. ಏನು ಕೇಳ್ತಿದ್ದಾರೆ? I ಕೇಳ್ತಾ ಇದ್ದಾರೆ. Therefore, I is equal to 5.7 minus 0.7 all divided by value ಎಷ್ಟು ಕೊಟ್ಟಿದೆ ಇಲ್ಲಿ I 5 into 10 power plus 3. So therefore 5 by 5 into 10 power minus 3, 5 get cancelled, 10 power minus 3 ampere. Minus 3 is nothing but what? Milli. 1 milliampere. Option 2 is right. Okay, I can switch on to the next question. Okay. Okay, thank you. So this is the idea about what? Semiconductor electronics. I hope you understood this topic. Okay, thank you.